This video will discuss and illustrate structural modeling tips and tricks in AdaptBuilder 2016.2. These include dynamic dimensioning in the graphical modeling interface, allowing the user to view both angle and length while modeling polygons like slabs or area loads, and also continuous lines like tendons, support lines, and splitters. The user can also see perpendicular, horizontal, and vertical projection lines, allowing the user to quickly and easily navigate and model slabs and continuous elements. We will also explore the settings associated with dynamic dimensioning, including incremental snap settings, as well as angle and length settings. These include the option to lock or unlock discrete inputs for angle and length. The undo and redo functions in AdaptBuilder have been stabilized and improved, including the use of the backspace hotkey to delete the last and previous input of a vertex for a polygon or a continuous line. The Enter key can now be used for closing and closed polygons like slabs, area loads, area springs, instead of having to select the C button to close or right-click and select Close. The copy and paste functions in the program using hotkeys Control-C and Control-V or from the Edit menu have been improved in both single and multiple level modes. The option to copy and transform a component or groups of components that have been selected can now be done using the Control plus Shift plus C hotkeys. In this sense, the user can select a group of components, use the hotkeys, select the base point, and then the insertion point from the group of components. Improved snap perpendicular functions have been included for linear and continuous components like tendons, walls, support lines, and splitters. The program will automatically detect the perpendicular location and allow the user to select that location in either modeling or editing mode of a component. The program now includes improved column duplication messaging when a column is placed at the same location as an existing column. We will now explore dynamic dimensioning, settings, and available functions when using this in the program. If we go ahead and just add a slab, I select a point for the start point of the slab region. You can see now that the program will view or show both the length and also the angle relative to the projection line. So in this case, the angle is relative to the horizontal line in the positive X direction, and that line just continues to grow, or the angle continues to grow as we rotate the slab around. It will also show a negative angle if we rotate the line in the clockwise fashion here. So we'll go ahead and add a few points for this particular polygon, and you can see once a first point is selected, now I have the ability to use projection lines. So this projection line is the perpendicular projection line to the first segment created. I can also reference vertical projection lines and also horizontal projection lines. We'll go ahead and click and close this slab. Now, new to this version of Builder, you now have the ability, instead of pressing C on the keyboard or right click and selecting close, we can choose to select enter to close any polygon. So here I'll just go ahead and remodel a polygon. I'll press enter on the keyboard. That closes that function, and I can go ahead now and create a new slab. If I select a point to begin a slab, you'll notice that the increments for length are shown here in 2 feet. The increments for angles are shown in 1 degree. And if we right click and go to settings, dynamic dimension settings, which is also shown by the hotkey S, so I'll go ahead and exit that, and if I press S, that will open the settings for me. You can see that the user has the ability to turn off the display of both the length, angle, and also reference lines, or you can change the increment for length and angle in these settings. If we right click and select dimension input, we have the ability to directly input the length for a given segment, also the angle. So in this case, if I wanted to set the angle as 0 and set my length, let's say, as 20 feet, and notice I'm keeping the lock length and lock angle unchecked, I'll select OK, and that's going to create that segment length that we just added. I'll go ahead and close that using the Enter key. I can also go to the direct length and direct angle input by just selecting the D, and that's the hotkey for set length and angle. Now we'll show how to use lock length and lock angle now. So we'll go ahead and cancel, and we'll go ahead and clear some of these slabs that we've created, and I'm going to just begin building a new slab. And let's say that we have a length here that's in the X direction. The next slab leg needs to be at 45 degrees from horizontal. So if I go ahead and just select D to go to the set length and angle, and in this case I'm going to lock the angle. The angle here we're going to say is negative 45 degrees. The length, we'll go ahead and adjust the length on screen using the mouse. We'll select OK. Now the angle between horizontal and the current segment is set to 45, and you can see that dimension shown for the angle, and I now have the ability to generate my length using just my incremental snapping for this line segment. However, if I wanted to directly input the length, I could press D. I could say, well, this length is going to be 45 feet, okay, and that will set the length for the particular segment. We can do the same thing with locking the length and leaving the angle free, unconstrained. So I'll go ahead and again select D to open that dialog, and in this case I'm going to lock the length to, let's say, 40 feet. I'll leave the angle alone, and now this length that we see here on this leg that's rotating is at 40 feet, and I can then swing that around to my position and continue building my slab. The undo-redo functions have been stabilized and improved for rapid use when modeling inside of the Builder interface. So for this slab that I just created, I'm going to go ahead and just add some columns and also some walls. So we'll go ahead and use different components in modeling in sequence or in a stack, and also let's put in a couple of beams here. And let's say we wanted to correct a mistake we had made. So we may not have wanted those two beams in that location or the wall. I can just use the undo function to go ahead and eliminate the beams. I can also select the redo function. This might take me all the way back to the blank screen or blank palette, and then all the way forward to where I was in my modeling. I also have the ability to use the backspace tool when trying to correct a polygon that's been entered. So for example, if I go ahead and enter a slab, and let's say I click on the wrong point here several snaps back, I can select the backspace button to go back to that location and continue with my modeling. And this is useful for other components like area springs or area loads, for example. So if we go ahead and build an area spring, I'll go to spring, area spring, and oops, I snapped inside of the slab when it should have been outside of the slab. So we can again press backspace, go back, and just fix that using the backspace hotkey for this input. Similar functionality is useful when modeling continuous line work like tendons, support lines, line loads, etc. So if we go ahead and just add tendon in this slab, we might have made a mistake here and selected the wrong location. So again, I can backspace to go back to where I need the tendon point to be aligned and correct that mistake. And that allows us to easily and rapidly delete points that have been added on a continuous line type element. The snap perpendicular functionality has been improved for modeling of components such as tendons, support lines, splitters, line loads, anything that might be a polyline or represented by a polyline type input. So if I select the option to add a tendon, I'll arbitrarily snap somewhere outside of the slab edge, add a few points inside the slab, and then select outside of the slab edge, and I'll go ahead and close that using the Enter key. And if I go ahead and select the tendon after it's been added, and now we're in editing mode, and I select this point, making sure that the snap perpendicular is turned on the snap toolbar, the program will now automatically locate the perpendicular location and allow the user to snap that point to the perpendicular edge. This also works when we're in modeling mode. So we'll go ahead and press enter, and again, if I, for example, outshoot this outside of the slab, press enter to close, and then I go back and readjust the tendon, I can either select this perpendicular edge or even this perpendicular edge to realign that line. This does not only work for tendons, it also works for things like support lines. So if we go ahead and create a support line, I'll do the same type of modeling. For this support line, I'll close the support line with enter, go back and readjust this on both ends using the snap perpendicular. I snap to this edge, but if I wanted to realign that up to this edge, that allows me to do that. I could also realign this point here up to this edge, for example. So there's lots of use for this functionality with the new perpendicular improvements. Go ahead and clean the screen here, and we're going to now explore the copy and paste functionality both in single level mode and also in multi-story mode. In order to do this, we're going to build a model from the wizard. So we'll go to build, floor wizard, and in this case we're going to create a 4-story model. And we'll go ahead and just run through the wizard, create tendons, loads, slabs, etc. We now have a multi-story model with multiple components. And if we go to full structure mode, I'm going to go ahead and reset this to the default display. We can see that this has 4 stories with some basic components added using that wizard tool. If I now want to copy and paste this entire system, all 4 stories plus the slabs, columns, etc., I'll go ahead and just select all of my components using Windows Select. I'll use Control C as my hotkey, Control V. The program now allows me to paste using any insertion point. And we notice that the program is actually snapped to the column at the lower left. This is the first component that was modeled via the wizard. So whatever your first component is, or the first point on a polygon, that is the component that the program by default will use as the base, and then the insertion reference for the insertion of the selected items. So here I'll just select that there, and I select this here. The default is for multiple replications, so now we have 5 different stacks of 4 stories. We can see all those copies made there. We'll go ahead and delete that. I'll go into single level mode, and I'm located at the current plane at this point. So if I do the same for a slab, I'll press Control C, Control V. You'll notice that the first point that was defined using the wizard was this point here, and now I can again copy and replicate that multiple times. If we want to exit out of this, we can just right click exit. Now we have 2 replications. Let's go ahead and turn on the tendons. We have tendons located in the slab at the bottom level. This is again at the current plane. This is the bottommost elevated slab, we'll call it. If I go up 1 level, we also have tendons at this level. So at the top plane, I'm going to delete my tendons. I'll just use select by type, tendons, and I'll delete those. I'll go back down to the lower slab. So this might be useful when you have a typical slab that you've designed post-tensioning for, and you now want to copy these tendons vertically using a similar origin at each of the levels. If I go ahead and select these tendons at the current plane, and I'll press Control C, if I go up to the next plane and Control V and I press O for origin, that's going to align the tendons relative to the origin that they were selected from the reference plane, which in this case was the current plane. So here if I try to snap my location for insertion, it's difficult because I don't have a reference point. But if I just press O on the keyboard, the program will insert those per the original source components that were selected to copy. And you can see those are pasted in the exact location as they are in the level below. We'll go back to multi-level view, and I'll go back to my default display. We now want to copy a couple of components and have them referenced from the same level from which they're selected. So Again, we're working on the current plane here, and a better reference view might be if we look at an elevation. We're at the current plane. Let's navigate vertically to the third plane. So we're now at third plane here. We can see that that's highlighted on the left-hand side. And I want to copy all of these columns just out to the right, but I only want them to be copied per their reference from level 3 down to the top plane. So in this case, I've selected the columns. I'll just go back to top view and I'll say Control C, Control V. I now have the ability to now choose a reference location in this view when we're in plan view. So I'll just select here, and let's also select out here. And if I go back to my elevation, we can see that because my active plane when I copied the components was plane 3, the new copies are also referenced between plane 3 and also the top plane. If I was, for example, to take these columns and I'm still working with reference to plane 3, that's my active plane, and I'll go back to my display here. This is top view. We'll go Control C, Control V. Now I'll go out here to the right so we can copy those groups of columns, go back to my plane here. You can now see because I selected the columns above plane 3, now they're referenced at the proper location from which they were originating. So they originated between 4 and 3, and they're copied at that level there. We'll now show how groups of components, including columns and slabs, walls, beams, whatever else might be included at a level, are referenced when we copy them to a level that might be above an existing group of levels that already has components assigned to them. So in this case, I'll go to the level assignment. I'll go ahead and just add a few additional levels here and close that. And we now have levels 9 through 6 that were added to this stack of existing levels. And so now we're going to go ahead and just select all of my different columns and slabs. Again, the reference plane here, it might be plane 3. And I'm now going to copy to plane 9. So the reference plane is 3. We have one level above that, and I'm copying to plane 9. So we'll go up here, and I'll go active level up. I'll go all the way up to 9, and I'll select Control C, Control V, and I'll go ahead and snap there to insert. If I go back to my view, you can see that the building was truncated. Because I had snapped on level 3 as my reference plane, there was one level above that. However, there's no level above plane 9 where I copied to. So the program will truncate that, and you're going to be left with whatever was at level 3 downward in the stack that was copied. To give you another sense of that, if I go back to my reference planes, this time we're going to go back down to current plane. So I'll use current plane as the reference plane here. I'll select my components. Now I'm going to copy this up to plane number 7. So I'll go back to plane 7 as my reference plane. Go back into plan view so I can select Control C, Control V, and locate that in the XY plane, and then go back into my front view or left view. And again, you can see that these are truncated. In this example, my current plane when I selected the components was here. I have 3 levels above that. I inserted that at level 7, and again we have a leftover level that can't be assigned because there's no reference plane above 9. So we'll go back and delete that, and we'll give one more example where we keep the reference plane. Again, we'll go back to current plane, and in this case I'm going to use plane 4 as my insertion plane. So we'll go back up to plane 4. I'll go back into plan view to Control C, Control V. Because current was our reference, plane 4 is our insertion. This plane here maps to this plane, and then we have the vertical stack which fits within the additional planes that we had created. Therefore, we have a replicate of the four stories and the associated components in this new copy. Instead of just copying and pasting a group of components without a reference point, we have the ability to copy and translate the components, and this allows us to pick an insertion point for those components. So let's just add an insertion point. We might want to copy these objects and have this marker here as the insertion point, or it might be another component as an insertion point. We'll just add another component here, a wall, and this upper point of the wall might be our insertion point. So in this case, I'm going to select my objects. I'll go ahead and select, notice I'm also in single level mode now, just working on one level. I'm going to now, instead of selecting Control C, I'm going to use Control Shift C, and the program will prompt the user to enter the translation base reference point. So that might be, for example, this column here, and I'll move that over to this marker, and then I can also move this, let's say, to this point here, and that allows us to copy those relative to a specified base and insertion point. The last improvement that we're going to discuss is the new messaging that occurs when we have a duplication of columns. And in this example, if I select the 4 columns, select Control C to copy, Control V to paste, and I go ahead and use an insertion point where these columns stack on existing columns, we now get a message that allows the user to select OK to continue the paste, or select Cancel to cancel out of the paste and select a new insertion point. If you have any questions, please contact our support group at support@adaptsoft.com.